Behavior of thermal dissipation and tensile properties of aluminum for ACSR. Abstract. The objective of this research was to gain a better understanding of thermally conductive and electrically insulating properties. The utilization of thermal conductive polymeric composites is growing up, where the polymers filled with the thermally conductive fillers effectively dissipate heat. Thermally conductive particles-filled polymer composites have advantages due to their easy processability, low cost, and durability to the corrosion. The better understanding of tensile properties of epoxy resin composites reinforced with hardener, the effect of laminates has been investigated and experimentation was performed to determine property data for material specifications. The laminates were obtained by hand layup process. The test-ready specimens were subjected to tensile loads on universal testing machine. This research indicates that tensile strength is mainly dependent on the orientation and thickness of laminated polymer composites. Keywords: epoxy resin, laminated polymer composites, insulation, aluminum for ACSR. Introduction. Energy conservation has become a major task to satisfy the energy need of world. Different methods are tried for conservation of energy. Thermal insulators play a big role in preventing losses of heat. Various types of insulating materials with sources from agricultural products and its wastes, industrial wastes, those have shown excellent insulating ability. Aluminum alloys are supplied in a very wide range of tempers with non-heat treatable alloys, alloys whose strength/mechanical properties are achieved by cold working, rolling, extruding, etc. Sometimes called work hardening alloys. Temper is denoted by letter H. ACSR, aluminium conductor, steel reinforced, conventional conductors with steel core. It's a bimetallic conductor. The inner layers are composed by steel wires and the external layers are composed by hard-drawn aluminium. The steel wires guarantee high mechanical performance. 0.1350 is among the EC or electrical conduction alloys due to its high purity of 99.5% aluminum, 0.15% Si, 0.4% Fe, 0.05% Cu, 0.05% Mn, 0.01% Cr, 0.05% Cn and others 0.03%. Alloy 1350 is widely used in a number of electrical and other industries due to its conductivity and formability. Teflon Polytetrafluoroethylene is the DuPont trade name for the polymer made from tetrafluoroethylene. The polymer has a linear chain structure of carbon atoms, to each of which is attached two fluorine atoms. It is capable of continuously withstanding operating temperatures in the range of 200 to 300 degrees Celsius. It is insoluble and is attacked only by a few rarely occurring materials. Its electrical losses are low, and its volume and surface resistivities are high. It has outstanding dielectric properties that remain stable with frequency and temperature. It resists ignition and does not promote the spread of flames. Teflon has a uniquely high bulk density. Excellent thermal and electrical insulation properties. Low coefficient of friction. Chemical resistant. Epoxy. The primary reason for epoxy's popularity is its superb mechanical strength. Epoxy also has excellent resistance to chemicals. After setting, there is no worry of a chemical reaction that will weaken the seal. It also resists heat. That resistance makes it ideal for electronics and electrical systems and other industrial applications. It has excellent gap-filling properties. Epoxy is resistant to cold, radiation, and steam. The superior performance of epoxy remains when exposed to adverse environmental conditions. Epoxy sets fast and can easily stick to fingers. Before starting a job, be completely prepared. Epoxy stuck to fingers is difficult to remove. Epoxy glue is a two-part resin. The parts are the resin and a hardener that reacts, chemically, when mixed. They produce a strong bond that adheres to nearly any clean surface. The components do not set while in the tube with the cap in place. Therefore, epoxy has a long shelf life. Epoxy set hard and fill gaps that add stiffness and strength to glued materials. Epoxy coatings are stain resistant. The cost of epoxy is economical and coating provides added safety. 2. Experimental. A. Materials. 1. Aluminum for ACSR. 2. Mila film. 3. Teflon. 4. Epoxy. B. Instrumental. The Megger insulation tester is a small, portable instrument that gives you a direct reading of insulation resistance in ohms or mega ohms. For good insulation, the resistance usually reads in the mega ohms range. See sample preparation. STEP 1. In any practical cases, before starting of operation there is some initial setup and some accessories needed. So we set all the external equipments at the operation time. Taking all the required materials and scaling is necessary for those materials. STEP 2. Completion of step 1. It required of some specific measurements for all materials. Measure the Teflon sheet for 10 mm diameter coating thickness and mix the epoxy resin with hardener in equal solutions. STEP 3. Take Teflon sheet and place it on the flat board. Spreading of epoxy resin which is mixed with hardener, bonding material, and equally on the Teflon sheet material. Place the aluminium on the Teflon sheet in operation of spinning action done by manual process. After finishing the process, Mila film is covered for certain time, approximately 36 HRS. All the corresponding figures shown below. After completing the process, leave at least 1 day for rigidly fixed in natural atmosphere. 3. Test configuration. 4. Calculations. The result in discussion. Description of the instrument, conductivity of aluminum for ACSR/aluminum wire for SSR grade. Size, 6 mm. Conductor, aluminum. Insulation size, 10 mm. Insulation, Teflon coating with epoxy. Conductivity of aluminum for ACSR/aluminum wire for SSR grade of 16 mm which include insulation Teflon coating with epoxy size of 10 mm which is kept at a temperature of 50 and 100 for about 2 hours. The status no change in size or diameter. From the above result analysis we conclude the result is positive. 6. Conclusions. An experimental and theoretical work has been completed in this research. This theoretical and experimental investigation on thermal conductivity of aluminium-filled epoxy composites have led to the following specific conclusions. Successful fabrication of epoxy-based composites filled with aluminium by hand layup technique is possible. Teflon is a very unique chemical in many ways. Its uniqueness stems from the way it was discovered and its chemical properties. The practical ways in which it can be used has led to being a part of many extraordinary things, is used as an insulation for communication cables, valves, seals, pipes. The effect of tensile properties of epoxy resin composites reinforced with hardener has performed to determine property data for material specifications. Load vs crosshead travel for both aluminium with and without coated material had a positive results for the laminates obtained by hand layup process. This research indicates that tensile strength is mainly dependent on the orientation and thickness of laminated polymer composites.